Hi, today we will understand Oracle database architecture. We have memory architecture in which we have SGA and PGA. We have physical file structure in which we have data files, redo log files, control files, parameter file, password file, and network files. We have Oracle process architecture in which we have user process, server process, and background processes. In background processes, we have multiple Oracle background processes. Some are mandatory and some are optional, like smon, pmon, ckpt, lgwr, dbwr, reco, arcn, mmon, lreg, and etc. Now come to SGA, which is known as System Global Area. In this, we have database buffer cache, redo log buffer, shared pool. In shared pool, we have library cache, data dictionary cache. Apart from this, we have large pool, Java pool, and stream pool. So these are the high level memory blocks present in system global area. Now we will deep dive into SGA and different memory components present in SGA. SGA is group of shared memory structure that contain data and control information for one database instance. Database buffer cache. It is largest memory area of SGA, which means suppose if your SGA size is 10 GB, so the maximum size will be given to database buffer cache. Like 7 or 8 GB or 6 GB will be assigned to database buffer cache. It stores the copy of data blocks read from data file, because every time any user requests any data from database, it reads the data from database buffer cache. All users connected to database instance shares access to buffer cache. Data in buffer cache is maintained with complex algorithm. It stores most recent and most accessed blocks in buffer cache. Next we have redo log buffer. It is circular buffer in SGA that stores redo data describing changes made to the database. Redo records is data structure that contains the information necessary to reconstruct or redo changes made to the database with DML or DDL operations. DB recovery applies this redo entries to data files to reconstruct lost changes. Shared pool. Shared pool catches various types of program data. It is involved in almost every operation that occurs in the database. For example, user executes a SQL statement, then Oracle database accesses the shared pool. In shared pool, we have data dictionary cache. It stores definitions of database objects and their permissions. Result cache. It stores the result of commonly used queries. It stores the result of functions. Library cache. It stores the execution plans, stores procedures, packages, control structures. Large pool. Large pool is specifically used by shared server connections to allocate the UGA region in SGA. Parallel execution of statements to allow the allocation of inter-process message buffers which are used to coordinate the parallel query server. Backup for ARM and disk IO buffer in some cases. Java pool. It stores all session-specific Java code and data within the Java virtual machine. Stream pool. It is used to buffer queue messages used by stream process as it moves or copies data from one database to another. Stream pool size can be manually defined, otherwise its size is 10% of shared pool size. Next we have program global area, that is PGA. It has SQL work area. Inside this we have sort area, hash join area, bitmap merge area, bitmap create area. Another memory block is private SQL area. In this we have persistent area and runtime area. Another memory block is cursors area and session area. These are the high level memory blocks inside program global area. Now we will understand the PGA in details. PGA is a memory region that contains data and control information for a server or background process. Access to the PGA is exclusive to the process. That's why sometimes it is known as private memory area. Each server process and background process has its own PGA. Session area. It stores session information of user. It stores session variable, login information and session status. Private SQL area. Persistent area stores the bind variable. Runtime area stores the execution state info. Cursor area. It stores the information of cursor. SQL work area. It is a private allocation of PGA memory used for memory intensive operations. For example, sort operator uses the sort area to sort a set of rows. Similarly, hash join operator uses a hash area to build a hash table from its left input, whereas bitmap merge uses the bitmap merge area to merge data retrieved from scans of multiple bitmap indexes. Now we are going to look into physical structure of database. The first one, we have data files. These files actually contains the data of database, and database writer process writes the data in data files. Online redo log files. These files contain the redo entries flushed by redo buffer. They exist in form of groups and usually multiplexed to mitigate corruption risks in redo logs. Next we have control files. It contains the metadata information, that is database structure and all that. Usually it is multiplexed to mitigate the risk of control file corruption. Next we have server parameter files. It is server side initialization parameter file. It contains all the parameter and their effective values. For example, different components, memory allocation details, etc. This parameter file is very important for database, and without this file we cannot start our database. Next we have password files. It contains the user details which have sysdba privilege, and it is required for users who want to log in as a sysdba from remote. Next we have network files. We have three network parameter files in Oracle. First one listener.ora file, second one tnsnames.ora file, third one sqlnet.ora file. Listener.ora file contains the details of listener of database. It can contain more than 1 DB service names. It is located in Oracle Home, Network, Admin, and then listener.ora. It is text format file and it is in human readable format so that we can easily able to open it and can able to read or modify it. tnsnames.ora file contains the details of database addresses for establishing connections to them. It is located in Oracle Home, Network, Admin, then tnsnames.ora. It is also in human readable form and we can easily edit this as per our requirement. SQLnet Aura file is the profile configuration file. It exists in server side and client side as well. The database server can be configured with access control parameters in SQLnet.ora file. These parameters specify whether clients are allowed or denied access based on the protocol. It is located in Oracle Home, Network, Admin, then SQLnet.ora. Archived redo-log files. Since online redo-log files are limited in size and number, hence to keep all the redo data in archived form, Oracle have archived redo-log files. These archived redo-log files are required in database restoration and recovery activities. Archived redo-log files are only found in database which are running in archive mode. Archived redo-log files are generated in below conditions. First, when online redo-log cycle is completed, that means since we have, let's assume we have three redo-log groups, redo 1, 2 and 3. Suppose redo 1 group is filled, then it will switch to redo-log group 2, and if it fills then it goes to redo-log 3 group, and if all three are filled, then Oracle want to use the redo 1 group again. So to use the redo 1 group again, it need to flush all the data anywhere else if database is in archive log mode. Otherwise, it will delete all the data from redo file and reuse the file again. So during this cycle completion, one archive is generated by Oracle, and the background process responsible for this is ARCN, that is archiver process. When manual lock switch is triggered with below command, that is alter system switch lock file. You can understand with this graphics that what is read lock cycle. Now we have process architecture. So the first one is user process, or we can say it client process. Any database user who needs to request information from database must first make connection with Oracle server. The connection is requested using database interface tools like SQL Plus and beginning the user process. User process cannot interact directly with database. Rather than it generates call through user program interface, which creates session and start a server process. Server process. Once the user has established connection, a server process is started to handle user process requests. A server process can be either a dedicated server process or shared server process. In dedicated server setup, the server process handles the request of single user process. Once user process disconnects, the server process terminates. In shared server setup, a single server process serves multiple user processes. Server process communicates with Oracle server with Oracle program interface. Next we have Oracle background processes. Oracle have so many background processes which runs all the time to keep the instance running and serve user requests. The count of processes may vary with database version. Some processes are mandatory and critical for database instance. They must be in running state, else instance will crash. Below are some top 5 mandatory background processes. First one is DBWR, that is database writer. Second is LGWR, that is log writer. Third one is SMON, that is system monitor. Fourth one is PMON, that is process monitor. Fifth one is CKPT, that is checkpoint. One thing you need to note here, if someone kills any mandatory background process, it will eventually terminate the instance. Now we will look into some mandatory background processes. The first one is DBWR, database writer process. It writes the dirty blocks or modified blocks from DB buffer cache to respective data files. DBWR is triggered in following conditions. First one, when dirty blocks in buffer reaches to threshold. When DB is shutting down with some dirty blocks in buffer. When checkpoint occurs. When server process is not able to find any clean reusable buffers. When table dropped or truncated. When table space is going to offline or read only or begin backup mode. Next, log writer process. Log writer writes redo data from redo log buffer to online redo log files sequentially. Log writer invokes more often than DBWR because online read log files size are too small as compared to database data file size. Log writer invokes in following conditions. Whenever one-third redo buffer is filled up, in every 3 seconds, whenever 1 MB redo data is generated, whenever user commits. Now we have system monitor process. SMON is responsible for instance crash recovery. SMON cleans up temp segments that are no longer in use. For example, when we try to create index on any table, then Oracle allocates extents. And if the operation fails, then SMON cleans up the temporary space. PMON process, that is process monitor. PMON is responsible for user process recovery. If user process fails, PMON will roll back user transactions. PMON free up the resources of processes which are no longer exists in database server. PMON registers information about instance and dispatcher processes with Oracle Listener. Please note here, from 12c onwards, we have a dedicated process, LREG process. It handles the instance and dispatcher registration operations with Oracle Listener. Next we have CKPT, that is checkpoint process. CKPT triggers the checkpoint event to synchronize all database files with checkpoint information. It ensures data consistency and faster database recovery in case of crash. When a checkpoint occurs, it will invoke the DBWR and updates the SCN of data files and control files with current SCN. This SCN is called checkpoint SCN. Checkpoint event occur in following conditions. Whenever database buffer cache filled up, every 3 seconds, during graceful shutdown of database, whenever begin backup command is used, when manual checkpoint is requested with below command, that is alter system checkpoint. Thank you for watching.